All right, so now we're going to work to figure out what could be a answer choice, and now these are all going to be factored answer choices down below, that could represent this polynomial. So we don't have to have the perfect equation, which we could find that also. We just need a factored form that would match with these roots. And so what we want to identify is there is a root of -7, -4, and 0. So these solutions, we need to know that they came from the zero product property, where each one of them, it's x equals -7, x equals -4, and x equals 0. Those were all solutions from one layer above them. The layer above them would have been that this 7 was on the other side with the x set equal to 0. So it was really x plus 7 equaled 0. And this -4 was over with the x also, so it's x plus 4 equals 0, and then this x is already equal to 0. Why that's important is because this came from a three-factored version, three-factor form of a polynomial, where this was in parentheses x plus 7, in parentheses x plus 4, and then that x, you could put it in parentheses, but it's just, in front or behind. There's just a times x, and then it would have been equal to 0. So these solutions came from us having these three products that we broke up using the zero product property. So here we're working backwards from solutions to what the factored form would look like. This is the answer I'm looking for down below. And so I just picked that answer, which looks like the first one. Now, the thing to know is that this works great with this situation where there were separate solutions. What's going to happen is we're going to get these things where our roots bounce off a particular x value. So each one of these conveniently were roots that passed through. I'm going to call them PTs for pass through. Okay, any PTs, any pass-throughs have a single, or they have an odd multiplicity. Of that root, which means it's an odd multiplicity on the factor. So on the root, and then on the factor. What I mean by this odd multiplicity, it's huge moving forward to know that each one of these factors just have a odd power. So they're all raised to, in this case, a 1. That number, that power, the multiplicity, gives you an odd exponent, an odd degree. So the multiplicity translates to a degree on the factor. Okay, so on the factor, you get an odd degree. Odd multiplicity gives you an odd degree on the factor. What we're going to have is these bounce-off situations. I'm going to call BO, and I'll explain why in just a moment. It's supposed to be funny on purpose. And we have, that's going to be an even multiplicity of the root, which is going to give you an even degree on the corresponding factor. So we're going to look at some examples that have some BO, and we're going to recognize why that will give us some higher power, or some powers that are even, as we move on to the next examples. So hopefully we selected that one, and then we're moving on. Here we have a nice parabola that has two single pass-through roots, pass through here, which means that these roots have single powers to make a nice quadratic. This is x equals -1, which came from x plus 1 as a factor. And this is x equals +4, which came from x minus 4 as a factor. So we're looking for this quadratic factored form down below in my answer choices. Now there's extra little x's and stuff that would make this a cubic function. That's not what we're looking for. We are looking for exactly what I wrote above. That one right there. Now we have our first opportunity to recognize a bounce-off root. So what happens is the graph comes up and it hits the x-axis at -4. It bounces off. It's got some BO, just like we bounce off from somebody when they got some stank. And so we go the other direction. It's like, ooh, I'll go the other way. It stinks right there. whether it's somebody or just some area where it stinks, we bounce away from that stink, right? So that bounce off is a even multiplicity, which means we need an even degree on the factor. Well, the factor is x equals -4, and so that came from x plus 4, and so that factor would have, if we weren't paying attention to this stink idea, this bounce off, if I wasn't writing and paying attention to this even degree, I would have just left this like that, and that would have been wrong. I need to put some even exponent. It could be a fourth, actually, but it's not because it would have a wider term. But this is a square, so we're going to put a second power, second degree on there. And then this one is a 3, so that's x equals 3. And if we go back, it would be x minus 3 that was equal to 0. So the factor x minus 3 is what we put next to this x plus 4. So it's x plus 4 squared, and then x minus 3, that would be multiplied next to it. If I was to graph this, like on Desmos or something, I would get a graph that looks just like this cubic function down below. And side note is I could count the exponents. I was supposed to change to green. The 2 here, and then I have one more power right here. 2 plus 1 is 3. This is a cubic, an odd degree overall. See how the hands go from here to here? That would be an odd degree positive a value function. So that's going to be important for later also, is that we should have the powers add to the right degree, which is odd for this graph. And then we just select that option down below. Now, they have it written for us, not squared. They have it just written next to each other twice, and that's okay. That's the same thing, because having x plus 4 squared just means having it written twice. So just recognize that and then select that answer right there. Now this one does not have any special bounce offs. These are all pass-through, so these are all going to be single factors. The one that throws people off is that crossing at 0. Anytime it crosses at 0, just know that the factor is x. You're going to have an x in your factor if it touched the x-axis at 0. So this is going to be x equals -8, which would have been produced by an x plus 8 that was equal to 0, and that solved to get x equals -8. This is x equals -4, which came from an x plus 4. And this x equals 0 came from just a nice x hanging out. So we're looking for the answer that looks like those 3 factors, x plus 8, x plus 4 times x. Everything's positive, and an x out in front. That solution right there.